Hey people, how's it going? Happy Monday. Last week was super cool because we got to spend some time outside, but now you're probably watching this video and you're like, man, I've got a lot of work to do, but no fear. Tomorrow we're going to review more about all the stuff that we may have missed in second period, and then we're going to take a short quiz, but as always, don't worry about it. We're going to get through it and learn a whole lot. Woohoo! All right, so we kind of went through this warm-up in class, but in case you don't remember, which is valid, let's talk a little bit about tangents, secants, and chords. So we talked about chords and tangents a lot. Tangent line is just this line that connects to one point on the outer rim of our circle or the circumference. And then we know that a chord is just a line within a circle, or a line segment rather, that touches 2 points on the circumference of our circle. So a secant, I don't want you to get too confused with the wording, but a secant is essentially just a chord that continues on past our circle. So we could call it a chord line, but in reality, it's just a line instead of a line segment. So there's that. Alrighty, without further ado, let's just jump into the notes that we missed last time, and then we can go over a few examples. So let's take a look at the top two first. So we're looking at when we have lines intersecting and it forms angles inside or on a circle. So last time we talked about what happens when two chords intersect, and what we have to do is look at the arcs that they're actually intersecting and say, I know that these two angles are not central angles. They're not the same. So what I've got to do is take an average of both of my arcs. So what I'm going to do is add together the two intersecting arcs and divide by 2. Now, why did I write it as multiplied by 1/2? That's just so you guys remember that what we have to do is add together those two arcs before we divide by 2. All right, we talked about that quite a while ago, but there's a refresher. And then what else do we have? What happens if we have a tangent line and a secant line? So I've got my tangent, that's xy, my secant, essentially a chord, but it continues on past and goes through the circle. That's going to be TV. So what I have to do in this case, looks like the document camera's frozen. That's always good. Alrighty, there it goes. Whew, all the technical difficulties. That's okay. What happens when we have a tangent and a secant line? Well, it's going to form essentially this cross here, and we are faced with a very large arc and a smaller arc. Now our secant can absolutely go through the middle and create two 90-degree angles, but what if it doesn't? All we have to do is take the measure of our intersected arc. So if I'm looking at angle T in this case, or this pink outlined angle on my circle, I'm going to take the arc and I just divide by 2 to get the angle measure. So when I have an angle that I'm looking for and it looks like it's on my circle with a tangent and a secant, all I have to do is divide by 2. Very similar to those inscribed angles. If you think back, take a look at those notes. We won't talk about them right now, but let's just start with that. All right, so let's talk through a couple examples. Here we go. So if I'm given these two secants and they're crossing, I'm trying to find the measure of angle 1. This is where I would ask you in class, hey, is there another angle that's congruent to angle 1? You're not there to answer, but maybe think about it. These are vertical angles, so I know that those two angles are congruent. But how do I find the measure of angle 1? Well, I've got two intersected arcs here, so what I want to do in this case is add them together. So I've got 52 plus 40, and then I want to multiply by 1/2. Another way to do this, what if I just divide by 2? That choice is up to you. All right, 52 plus 40, we get 92. I'm just going to divide by 2. What do I get? 46 degrees. So the measure of angle 1 is just 46 degrees. All right, keep on moving. We've got something a little bit different, but this looks super similar to an inscribed angle that we talked about quite a while ago. But just like our notes, what can I do? I know that the intercepted arc is 92 degrees. All I have to do is divide by 2. 92 divided by 2, conveniently, 46 degrees. How did that happen twice? No idea. No idea, but pretty cool. All right, angle 3 here. That's what I'm looking for. I've got this beautiful arc, and all I have to do is divide by 2, so I get 110 is measure of angle 3. Almost wrote 100. All right, so number 4, a little bit more thinking to do here, but nonetheless, we can do it. So I've got this angle, and I know that that is 90 degrees in total. But what I'm actually looking for is the measure of angle 4, which is this small piece of my 90-degree angle. So it's not going to be 90, but what can I do? I'm given an arc, so I can find this other angle. So all I have to do is divide by 2. 120 divided by 2, I get 60 degrees for this angle. But that's not angle 4 quite yet. So all I've got to do, I'm sure you guys are thinking it, what if I just do 90 minus 60? Since I know that that total angle is a right angle, that's all I've got to do. I get 30 degrees. All right, let's take a step back. We've got the same process, but this time, what I want you to note is that I'm looking for the measure of angle 5, but what I'm given is these arcs that are intercepted by these other angles. So I can't just right away solve from the measure of angle 5, but I know a lot about circles at this point. So let's piece it together. Let's solve for, we'll call it angle W first. So what I have to do is I'm going to take the average of both of my arcs. I'm not going to divide by 2 this time. I'm only going to do that when I have an angle on the kind of outside edge of my circle. So 130 plus 90 degrees, make sure to do that first, and then I'm going to divide by 2. All right, so that in total is going to leave me with 110. So I know that this angle here is 110 degrees, but what I don't know is the measure of angle 5. So since these are vertical angles, I know both of these are 110 degrees. And think about the total angle measure for a circle. That's going to be 360 degrees. So what can I do? What if I do 360 and then I subtract 110? And then I subtract 110 again because I know that those are vertical angles and they're equal. And then what I'm going to end up with is 140 degrees. So I know that the remaining angles, which happen to be these two, are 140 degrees. And those are also vertical angles, which means they're congruent. So to find the measure of angle 5, I'm just going to divide by 2. And I should get 70 degrees. All right. Pretty awesome. Okay, one last one for this section of notes. Let's go through it. So I've got an arc's measure, and I know that the measure of that arc is 160 degrees. So what can I do? Let's go ahead and find this angle here. All I have to do is divide by 2. I know that this is 80 degrees. Now, think about it. I know that the total measure is 360 degrees all the way around. So what I can do is find what makes this 360. So 360 minus 160, this is 200 degrees for my arc. And then all I have to do is divide by 2. So I know that the measure of angle 6 is 100. But there's another thing that I want you to catch here. I've got this tangent line. And remember, when I have a straight line, I know the angle measure of a straight line is just 180 degrees. So after I found that this is 80, I absolutely know that the measure of angle 6 is just 100 degrees. All right, awesome. So the catch with these is not necessarily the math. I've talked about it a couple times in class, but it's not how well you can divide by 2 and add together. I'm not too worried about it. You guys are really awesome. But the key is choosing which one of these formulas or theorems or properties, however you want to think about it, I need to use. So that's all dependent on my image. So referencing back to your notes is A-okay. It's awesome. I expect you to do that. All right, let's talk a couple more. It looks like a lot, but the equation or formula for all 3 of these is exactly the same. I just want to show you a couple different ways that our lines can be set up so that we can use it. So intersections outside a circle. So that means I've got 2 lines, and what I'm looking for is this angle on the outside of my circle. So when I have an angle on the outside, I already know it's going to be a bit smaller. So instead of taking the average, I'm going to take my larger arc and I'm going to subtract my smaller arc. Notice how it's intercepting 2 arcs this time. So anytime I see this, I'm going to take my large arc minus my small arc and divide by 2. The process is the same regardless if I have 2 secants, a secant and a tangent, or 2 tangent lines, right? I'm still intercepting 2 arcs. All right, I'm not going to spend a ton of time on these notes because we talked about it possibly a little bit in class, but here they are for you. Let's do practice problems. All right, couple more. We might not go through all of these just for the sake of you watching a super long video, but let's take a look at the process. So what I'm looking for ultimately is an angle on the outside of my circle formed by 2 lines. So let's start by looking for the measure of angle 1 first. So what I've got to do is I notice that I've got 2 arcs that these lines are intercepting. So I'm going to do 80, my larger arc, minus 40, and then I'm going to divide by 2. So 80 minus 40 is 40, divide by 2, I get 20 degrees, and that's the measure of angle 1. So once again, not the most complicated math, but pointing out, man, which one am I going to use is the hardest. So be sure that you've got those notes by your side when you're working. All right, number 2, this time we've got a secant and we've got a tangent line. They look more like segments, but I could make them continue. No problem. All right, so I've got my larger arc and my smaller arc, and all I've got to do is take my larger arc, 160, subtract 80, and then divide by 2. 160 minus 80 is just 80. Divide by 2, and I'm going to get 40 degrees for the measure of angle 2. All right, let's take a look at number 3. So I'm still looking for that outer angle, but what I want to be careful with is I don't know my arc measure here. But from what I've got 2 tangents this time. They're hitting a single point in my circle. So what I absolutely can do is find the measure of that arc. I know that the angles in a circle all add up to 360. So what can I do? 360 minus the arc I have, 220. And then what am I going to get? 140. So 140 degrees is not the measure of that angle that I'm trying to find, but it's the measure of that arc. And then from there, I can go about solving. So I take my bigger arc, 220, subtract my smaller, 140, and then I'm going to divide by 2. All right. So I should get 40 degrees for angle 3. All right. Let's just go through one more. All right, so number 4, why not? This time, I actually have that angle on the outside that normally I would be solving for, but I want you to remember with any equation, I can have a variable in it and I can absolutely solve. So what I'm gonna do is my bigger arc, 70, I know that this smaller arc obviously is smaller and we're gonna call that x, so I've got 70 minus x, and then I'm gonna divide by 2. And that should equal this angle that we're given, which is 20 degrees. So first step to solving an equation, I've got to get x by itself. So first step, multiply that 2 out. Let's get it out of the denominator. 70 minus x equals 2 times 20. So I get 40. All right, let's go ahead and move the x on the other side, make it positive. 40 plus x, and then I'll just go ahead and subtract 40 from 70, and I should get 30 degrees equals x. And that is the arc measure. Awesome. So I'm going to stop there, but all in all, great job watching the whole video if you got here. If not, well, I guess you're not here, so I'm not talking to you. But remember, reference those notes. Really, the hardest part here is just knowing which one of those formulas to use. So if you stuck with me all the way through here, I'm confident you can do the math. I know you can do it, but just focus and try to get that practice done. Use your notes this time. There's always time for memorization, but what I really want you to get is just looking at the diagram and saying, I know which one of those formulas to use. Alrighty, guys, have an awesome Monday. Excited to see you later this week. And guess just see you later. All right.